Hello everyone, welcome back to my channel. In this video I'll be going through the 5 things that every Pygame project needs, and I say needs as in it needs this to be what I would consider a reasonable Pygame project. So I've made quite a few Pygame projects, and I'll be going through some of the code and the best bits to show you what you need to do in your Pygame project. So we'll just start. Right, so the first thing every Pygame project needs is an initialization function. Now, what this means is there's some sort of series of statements that will tell your computer to start up Pygame and to get it working. So basically, what you need to do is you have to have pygame.init. Right, so pygame init. What pygame.init does is it initializes all the imported Pygame modules. Basically, it sets up Pygame, and without it your program wouldn't work at all, or at least it wouldn't have Pygame properly initialized. You may import it, but it won't work. And basically, if we just run this now, we'll see what happens, and what you'll get is just this message, hello, from the Pygame community, and then, pygame.org/contribute. Doesn't really matter, but what it shows you is that Pygame successfully initialized and that it works correctly. Right guys, so once you've done initialize pygame.init, you see that it works. Okay, what next? Well, in this bit I'm going to be showing you how to get the black screen, because obviously Pygame's a graphical library. You don't just want, text. That's not what you want. So what we'll get is, if you look at this line here, we'll do screen equals pygame.display.setMode, and this is set of size. So as you can see here, we've set size to the width and the height, which is 800 by 800, so this is in pixels, and as you can see this is a tuple. This is because that's just the parameter the setMode function takes, and it returns a screen object, which we've labelled screen. Now the clock is what you need to Pygame project in sync with everything, which is how a clock on the CPU works. It's the same sort of thing. It ticks and it keeps everything running. I'll cover this more later on. That's just how you initialize it. The time.clock just returns a clock object, which is what we've got here. And text font is used if you want to display text graphically on the screen. All you have to do, you use the sys font, and you just pass the name of the text and the size. This is the same sort of size that you'd use for Word, if you're familiar with that. And obviously, lastly, if you want to set a caption, which would be the sort of this bit here on the screen, you just pass in a string and it sets it. So if we now run this, as you can see, we've now got our Pygame. We've got our Pygame screen. So we've got a black screen, and we've got a caption. It looks like it's all working. So if we just want to close this, oh wait, we can't close it. This is because you haven't got an event loop. If you don't have an event loop, then, well, Pygame's just collecting all these events, but it's not actually using them. So I'll talk about that, because that's the second thing that every Pygame project needs. Right guys, so in the first part, you saw that, when we tried to click X and close the window, nothing happened, or at least that's what it appeared to be. Something did actually happen, and I'll be explaining that now. So the second thing everyone needs in a Pygame project is an event handler. This is the most basic type of event handler, and this function right here, or some would call it a procedure. Actually, quick side note, subroutines is a reusable block of code which is also named and can be referenced. Procedures are subroutines which don't return any sort of value, and functions are subroutines which do return a value. As you can see, there's no value returned. However, in Python, not Pygame, in Python, the language, by default, every function, because I'm calling them functions, does return a value. So when you put it through, when you compile Python into the bytecode, which is then later interpreted, when it's being compiled into the bytecode, everything is being returned. So what I mean by this is that every function does actually have something returning, which is just the none value. Pygame has a built-in value called none, which is this. So it's basically like going, oh, at the end of this you just do return none. This actually, I believe, happens in the lexing stage. So when it goes through the lexer, it's added on to the end. But I'll have a full video going through how Python works as a language, maybe in like a few weeks' time. Anyway, back on track. I might edit that bit out, so I don't want to get this video too rambly. But back on track. What this does is it goes for every event in the Pygame event queue, because there's this built-in sort of structure in Pygame called the Pygame event queue. And what happens in the Pygame event queue? Whenever a registered event happens, so perhaps when you click X, that's called a pygame.quit, that will be put into the queue, right? So what this does is it loops over the queue, and it will go, if there was an event of type Pygame quit, then we'll run Pygame quit, right? So if we were to run this now, nothing would happen because obviously we're not calling this function anywhere. So the next bit that I want to add in is, this is still part of the second thing, is what you need to have is, ideally you want to have everything inside of a main function, right? And then you want to call the event handler. So if we just do while true, this is just an example, we do event handler, we just call that, and then obviously because we've put in the main function, we'll have to go at the bottom and go if underscore main equals underscore main, then we'll run main. I'm not going to really cover what this bit here means, but essentially it just checks that this is the main program. So if we run this now, I'll have a video on that later. If we run this now and we go around, now if we click quit, it will quit. Now with idle, you'll have to click do you confirm that you want to kill this, because it's currently running. But say if you had it in just the command line and you had the terminal open, it would just close automatically. It's just a quirk with idle. But yeah. Right guys, so this is part 3. The third thing that I think every Pygame project needs is a settings folder. Or not a settings folder, but more specifically, some sort of a file where you can get settings from, right? So what it does is it just cleans up your code and it makes everything easier to understand, rather than having a bunch of constants and variables defined at the beginning. What you can instead do is you can have it defined once in the program, rather than having to define this in every separate file. This works especially well when you have perhaps maybe 4 or 5 separate files. So we'll run into an example of this later perhaps. So what you do is you just do from settings, you import all. This asterisk here just means all or everything, and as you can see, this file here is called settings. This runs exactly the same, so if we just run it, it will run exactly the same as beforehand. Everything works. You click close, everything works. And as you can see, even though we're using, say, height and width, or specifically size here, and we've not defined anywhere in this function or in this program at all. But if we go, well, this file, if we go over to the other file, the settings file, then we've defined it here. This is actually really powerful. So, as I said, for example, this can be really powerful because obviously these settings aren't used in the program, but this is just a snippet from one of my other Pygame projects, where if you have all these dictionaries here with all the colours, and then you can even use the colours to define other specific colours. So say you want the text colour, the button colour. As you can see, this was taken from Commons Game of Life. And yeah, well, it works really well, and especially considering that in that example I had 4, maybe 5 separate Python files, and instead of having to define these at the top of all of the files, I defined them once, which is really good for efficiency's sake. Right, so this is part 4. in part 4 I'll be showing you the fourth thing that I think every Pygame project needs. And now, of course, what that is a menu system, right? So it instantly takes your Pygame project from being somewhat mediocre to pretty good. So all you need to do is, I've made this separate sort of module which just has the start menu, and this is the whole thing for the start menu. As you can see, we've got our own little event loop in this, as well as an event loop in here. But all you really need to focus on is, if you want to take this and put it in your own program, all you need to focus on is, well, the menu handler and this. So with the menu handler, what it does is, and it just goes through and, well, I'll just show you actually. It'll be quicker if I show you. So as you see, if you close that, this is what the menu system looks like. So you're probably thinking, okay, it doesn't really look that great, but this is a functional menu system. So what I mean by that is it works. It works really well. It's quite efficient actually, and you can just add in like sprites. So instead of having just draw boxes, you can draw your own graphics and import them. So if you click start game, it'll start the game, and as you can see, this is taken from my Conway's Game of Life, one of my older projects. So this may not be up to date as much, but it's got 3 buttons. You can add this functionality to add as many buttons as you want. These buttons are also scalable, so even though I can't scale this screen, if you wanted to make it scalable, the functionality is already there, and you don't actually have to add anything new. So if we click start game, obviously it just runs into the game. That's not really important, and obviously if we rerun this, this is an older project, so I didn't actually think of putting functionality on, maybe pressing the escape key to go back, but you could easily add that in. If we click quit game, it works as well. Iterative game is just another game mode, but it's just to demonstrate that you can have as many buttons as you want. So I'll just quickly explain this. So when you call the menu handler, you have to have these, I'll call them parameters. You need to have the menu mode, the screen, the text font, the text color, and the button color, right? Basic colors. You could also add maybe the text color for buttons. So all you'd have to do is just do button text color perhaps, and then you can just change it here. In this file, it will be just as well, I do apologize. I have tried to make this readable by making the text bigger, but of course that doesn't really work as well, considering I've got a relatively small screen. So we'll just forget about the other file for a minute. As you can see, it just goes while you're in the menu, which is set up here as true. If the menu mode equals start, which is the only current menu mode, but I've made this so say if you wanted to go, I don't know, if menu mode equals, I don't know, settings, then that would also work just as well. And you can just copy the same sort of layout and put it in here, which I have done in another previous project, which I might show you. Actually, no, I will show you after this, just as a quick thing. So all it does is it initializes an object of the class start menu. It passes in these parameters. It sets up the menu, and you don't really need to know how the menu system at least works. You just need to know how to interface with it. I will be explaining how it works, but you can always skip that bit. Right, so here we go. It gets all the button objects, it checks for collisions, displays the buttons, and then checks if everything's clicked. Checks if there's a click, which I'll be explaining in a second. So if I just put that there, and then open this one up. Right, so what happens? Well, first thing, we set it up. What I've done here is it just sets the title, it fills the screen black, and yeah, so we'll just go through each method one by one. So draw text, essentially it just gets the text, it turns into an object, and then it just displays on the screen. Well, yeah, it displays on the screen, and it centers it, which is a useful feature that I've added, and I hope you guys will appreciate this. Now, with the getButton objects, I've actually added functionality for as many buttons as you want, right? You just have to change these three parameters here, and you can have as many buttons as you want. This is an older project, or an older example at least. In more modern projects that I have, which I'll probably link down below in the description, I've actually set these as attributes of the class, meaning that you can just pass it in and set these attributes remotely without actually having to even open this file. You just have to have it installed. So what it sets all the buttons, it gets the X and the Y for each of the values, and then it just initializes all the button objects. So checking collisions is just another event loop. So what this does is it gets the mouse position, which is as simple as pygame.mouse.getPos for position, and what this does is there's also I believe there's a position queue of the mouse. So what it does is each event loop, very much like the other event queue, I believe they may be the same in the same queue, but they're accessed through different means. I believe you can also access it through the event queue though. What it does is it just gets the X and Y values of the mouse, which is very simple. And what this does is it just goes for each button, it checks if the collision points are with the mouse, and if that's the case, if it's also been clicked, then it will run the command, which you'll see later. And then finally, display button, all it does is it just goes through and it displays them up to the screen, draws the text, and then it displays it. This of course here is so that you can expand upon it, and enumerate. Basically what enumerate does is it iterates through the loop, iterates through a list rather, in a loop, and it will return the index and what's stored to that current index. It's like range, but in general it's just neater, because rather than having to go object at this index, you can just do object, right? And then if clicked is just the event loop. Right, so this is the example I was talking about. Here's the start menu. It's laid out slightly differently to how I showed you last time, but it's essentially the same sort of stuff, apart from this time you now have settings, which is additional functionality you can add. Don't worry, I'll be adding all of this code in the description below, so you can check it out at your own leisure. But as you can see, if the menu mode isn't start, then it could be game over, high score, settings, snake color, you know, anything like that. And this actually allows for multiple layers of menus. So if I just run this program, hopefully it should work. Yeah, it works. Okay, that's good. As you can see, it allows you to add more buttons than you want. So say if we go into settings, well then look, and then there's multiple sort of layers in these setting menus. Now of course, well, this is just a debug mode that I had on to check that it was working. So you want to set it to easy, and then it goes back, and you can also go into settings to color, all the same. That's it basically, it works. So that's just a demonstration of how far you can take this, and don't worry, if you're not happy with the aesthetics of the menu, you can always change this by, instead of drawing your own things using the Pygame draw rect, you can just import sprites, which you can you know, do pixel art or whatever. So this is just how powerful these menu systems can be. Right guys, so the last thing of course is particle systems. Now particle systems is what you add into any sort of Pygame project to really sort of spice it up, right? So I'm sure most people are familiar with Unity's particle system, perhaps not in a development sense, but in the sense that it's very good. Although I guess there is some debate about that. I have used it a few times, and I would say generally it's been a positive experience. So before I explain how the particle system works, you can see this is what it is. I'm going to be demonstrating it in a game that I've made, maybe, actually thinking about it, it's probably close to about a year or so ago. So this was like, I'd been using Pygame for a couple of years by then, but I hadn't really you know, gone into it as much. Okay, editing Fraser here. I'm re-recording this part of the video because I forgot to take out the music, which is quite loud, and it got amplified because I had it on 100, beforehand, and I have it on 100 now. So I'm just going to show you the thing. Anyway, well, basically what happened was I had like a mini heart attack, and I'm probably speaking a bit louder than I was beforehand, which I'll try to fix in the editing, just because I've gone slightly deaf in one ear, because my ear was literally right next to the speaker, well, like 5-10 centimeters away from it. So I'll just show you it. This is the particle system. So it's loading, and here you go. That's what it looks like. Hopefully I've done it correctly this time, and I won't have to do it a second time. But we'll see, because I'll have a third bit in. No, I won't. Anyway, back to the rest of the video. Right, so here's the particle system close up. I'll be explaining through it, and hopefully this will be educational and really help you out. So, particle system. It's very impressive. Well, at least for in the game it's impressive. The code itself perhaps is not, because it's actually relatively simple. It's about 50 lines, and this is, I wouldn't say on par with Unity's particle system, but I would say it's, pretty reusable. So with the particle system, you just have the single explode method. It takes a trigger value, the x and y, and the color of the particle. So the trigger value is the value that you set as, this is a Boolean variable. This just is, well, it acts like a trigger, like any other trigger. If it's true, then it will create the particles and set them off in directions and everything. If it's not, it will just skip through it. But as a performance boost, I found that if you did call the explode method every clock tick, even if you weren't going to be using it, I found it, this might be a bit counterintuitive, but I found it as a performance benefit. Now, this was just through trial and error. I'm not actually 100% sure why that was the case, but it works. Like, don't fix something if it's not broken. That's what I was thinking of. Anyway, so it supports different colours, right? So it's at the moment I've got gold and red for golden apples and red apples, but you can have easily as many colours as you want. Now, the trigger, what this does essentially is it initializes all the particles with the blast radius. It then sets off their directions on where it's going to be going, and then it creates the sizes of the particles. And then after that, it goes through all the particles and it displays them to the screen. And yeah, that's basically it. And that's what gives you the effect of particles. Honestly, it's really not that complex whatsoever. It just creates the particles, sets the directions and the sizes, and it just goes through the particles, and it increments all the directions so they all go off in their own directions. And that's basically it, really. So yeah, that was basically all 5 things that I think every Pygame project needs. Thank you so much for watching. If you got any questions or any other things you want me to do topics on, just let me know in the comments. Also, do subscribe, do like, and well, yeah, thank you very much for watching. Bye.